Yeah, thank you for coming. Today we'll be talking about a topic named firewall for routing. Okay, so previously we know Mikrotik has firewall, and then Mikrotik, of course, is a device for doing routing. So what's the difference between firewall and routing, and then how is it possible the firewall can support routing, and then what is the relationship between firewall and routing? All right, okay, let me check the, yeah, right. So agenda, first we'll be talking about the firewall concepts, and then later on we'll be talking about the routings. Okay. uh, Yeah, so we'll be talking about firewall first, and then the routing, and then we talk about the firewall for routing. Okay, for some of you, maybe you already heard about this regarding the firewall that can be used for routings. Some uh, can see this as a PBR, policy-based routing. Okay, so that's the topic that we'll be talking about tonight. Okay. Um, yeah. Okay, introduction. We are GLC, Garda Lintas Cakrawala. So we are based in Bandung. Areas are training and IT consulting. We also do maintenance and then developing our own solution for um, IT organizations. One of our product is GLC Radius Manager. It is a software that can manage your um, ISP organizations related to the customer. So with the Radius Manager, you can manage billing, payment. Okay, we have integration with Stripe, and then disconnection and then creations automatically. We also have regular event here every Thursday night, every week with different topics. And you're feel free to join us if you're interested. The topics mainly are related to networking. Not only Mikrotik, we also do Cisco and then Ubiquiti, somewhat Juniper, and also Linux, and then programming things. All right. My name is Ahmad Mardiansyah. You can call me Ahmad. I'm based in Bandung. I'm Linux user since 1999, Mikrotik, and then Ubiquiti. Certified trainer, consultants, contributors, and then if you have LinkedIn, I would like to connect with you guys. So hopefully we can make friends here with this webinar. Right, so past experience, this year we had a project for network support and radios and billing integration. I think it is a good opportunity during the pandemic. Yeah, we do network support if like remote installation, remote configurations, monitoring, and then support the integrations for radius and billing. Billing is important so that you can maintain a scalable network while keeping the number of human resource at the same level. So that's one way to scale up your organizations. And previously we had project in Congo, Africa, in Malaysia, in United Kingdom, in Libya, and in Korea as well. For details, you can see my LinkedIn. About the webinar, started in 2010. We do it since almost 1 year. We already done webinar every 1 week. So hopefully you can join our webinar. We have a Google Groups, based on email. Hopefully you can if you subscribe the Google Groups, and then sorry, I have a request here for displaying only the slide. Okay, so that you can see the slides clearly. Okay, I will do it now. Okay, and then share. Right, so can you see the slide? Hello. Okay, great, thank you. Okay, next is, okay, that was about ourself, our organization. So that's what we do. And then for yourself, I think some of you already introduced yourself here. Some of you are Indonesian, some are not, some is very far away. So I think the most farthest is from Philippines. Oh no, I got the person from Greece. Oh wow, very far from here. It must be very, very. It is. I think it's afternoon there. It's already dark here because almost 15 minutes to 8 o'clock at night. Okay, thank you very much for coming. Really, really appreciate that. Okay, hello. Let's talk about the firewall concept. So the webinar is only, yeah, in the beginning I was thinking to discuss about the whole firewall and then routing, but later on when I'm thinking, oh my God, I think it's too much. It's too much. The topic is too big. So I was thinking to make a, okay, just firewall for routing, not the whole firewall, because the firewall itself is a big topic. And then routing itself, it's not a big topic. If you combine and then you just blow up your head. So yeah, I just picked the firewall part that can be used for routing. Okay, right. So what is firewall? So firewall is a feature to control network access. So here is filter. Look guys, if you are new, and then I think whether if you take a Mikrotik course here, because the thing that I'm talking about tonight is not for beginner, okay? Yeah, it's not for beginner, so sorry for that. Yeah, this is for beginner. I mean, most of our webinar are for beginner. But this part, I think you need to have an experience first with the Mikrotik. So it's not something that, oh, I don't know anything. I just want to learn my firewall. Perhaps this webinar is not for you. Well, again, back to web. Back to the topics. So Mikrotik Firewall. So there is a menu named IP Firewall, and then inside you see the filter, and then the NAT, and then the mangle. So filter is used for, what is it? So is the sorry. Okay, so let me check again. Okay, let me share my slide only. So is it better now? Okay, yeah, great. So yeah, it's full. Yeah, thank you. Yeah, previously I just share my whole screen so that the slide is a little bit smaller, and then some of you perhaps maybe you were joining from the mobile phone. You cannot see it clearly. Yeah, so hopefully you can see it better now. Yeah, back to the topic. So firewall is a feature for control network access. So this is the main function for a firewall, right? Firewall. So in the beginning, when I learned I learned networking in 2000. So it's a long time ago, 2001. Yeah. So it's 2001. I started to do pinging, and then those new V things. I got my CCNA in 2000, and oh, it's a long time ago. 2002 or 2003. At the time, there is no exam dumb. Okay, you cannot Google the MTCNA, CCNA questions. Dumb. Okay, so you have to really understand the materials and then pass the examination. Okay, so yeah, back to the firewall. So in the beginning, when I learned firewall, is mostly is for filtering. Okay, so you can access this network, you cannot access that network. Okay, so that's the main purpose for the firewall. And then here, it's accommodated by a filter table. So basically, it's developed from Linux IP tables, but I don't know now. Okay, so previously, I don't know because the Mikrotik Firewall is based on Linux kernel, yeah, but the firewall feature itself, maybe they can make their own. Okay, so first is the filter, and then also you can do NATing here. So NAT is for changing the IP address, either source NAT, where the source IP address will be changed. Usually when you do a network translation from the private network to the public network, okay? Also, the third one here is the Mango, okay? It's for marking packets, okay? Firewall has, Mikrotik Firewall has two parts. First is the matchers and then the action. Action can be drop, allow, or change the IP address, and then marking. Okay, so those are the actions. Firewall is executed sequentially, and then network administrator must understand application characteristic for building the matchers. So for example, the ordinary users only say, okay, block the browsing. Well, browsing has to be translated into the technical term. So it means that the application, it means the browser will access using TCP port 80 or 443. So I forgot to add 443 here, because if you just block 443, many websites now are using HTTPS. Okay, so your filter will be useless. Okay. This is how firewall works, especially when you add a, this is a filter rules. Okay. So you have a matchers here. So so there are so many matchers. So you can match based on the source IP address, source destination IP address, or both of them. Okay. You can match based on the protocol. For example, I want to uh, stop the UDP protocol. Yeah, it's possible. Yeah, you can display them here. And then previously it was peer-to-peer. Yeah, so it was taken from this slide was taken from uh, many years ago. So at that time, the feature for peer-to-peer is available on Mikrotik filter. And then you can match based on the interface list. This one is cool. Packet mark, connection mark. So these guys are different, okay? And then they have a routing mark, connection type, connection state, NAT states, and then so on and so forth. Here in the extra, you can set based on time, okay, which is really cool. For example, you want to allow YouTube access start from 9 o'clock up to 12 o'clock, okay, from 9 to 12, okay. So that one is can be done from here, from the firewall, which is very cool. So on the other side, so after you do the matching, and then you do the action. Okay. So it's up to you. You can do accept, just accept the the traffic, or you can use you can write, you can catch the destination IP address, source IP address. You can drop them. You can do fast track jump. This is for jumping to other firewall rules in order to reduce the total number of firewall. This is very good, especially if you are in the live network and then you have lots of requirements from the for the organizations. Others are reject. This is a return. Return is others. Is used in conjunction with jump. Okay, after you jump and then you do return, and then target. Okay, so mostly the filter that you are using are drop or reject or accept. Okay. Okay, so those are for filter. And then when we talk about the processing, we need to understand the packet flow. Okay, this is Mikrotik packet flow, right? The way it does is when a packet coming to an input interface, the firewall check is the input interface is breached or not. If not, and then go to pre-routing. Okay, the pre-routing, if you zoom it, so it's going to be like this. Okay, so this is the whole pre-routing process. Okay, and then after that you finish, go to routing decision. So this step, you will be reading the IP route. Okay, slash IP route. See, slash IP route. Okay, so this is the place where IP route is read. After that, IP route will decide whether the packet is forward to other destination or the packet is input to the router itself. So when you ping the router itself, it goes to input. So note that previously there was an IPsec here, but I was removed in order to make the a packet flow more clearer. Okay. Well, this is not complete, but for most cases, this is sufficient. Now the packet flow is updated with the complete one. So for the beginner, perhaps it's a little bit intimidated, but it's complete. Okay. Yeah. Okay, so after it decides the packet is forwarded, it goes to forward, checking whether the output interface is breached or not. If not, and then goes to post routing, and then queue, and then output. So that's how the packet flows on the Mikrotik. Okay, you guys, if you have questions, you can write something here. Okay, and when we talk about the firewall, that depends on which firewall you're talking about. So the first firewall is filter. Filter is available on input, forward, and output. Okay. So let me pick another color. Okay, so filter is here, here, and here. For NAT, it only happens on here, only two places. Okay, pre-routing and post-routing. Okay, for Mangle, it happens everywhere because it's used for marking. It's available on pre-routing, output, forward, and post-routing. Okay, so all of them are there. So this is the sequence. Okay. Yeah, so you need to understand the sequence, how the package is processed. Otherwise, you just get lost. Sometimes I can see many people are confused when understanding the difference between input and forward. So input is when you access the router itself. Okay, so when you ping the router, when you access the router using Winbox, you'll be using input. Okay, and then after the request is processed here, and then the router will do output. Okay, check the routing decisions, output, and there. For forwarding, so when you are, this is a router. So because, for example, this is router 1, okay, and then this is router 86, for example. This is router 21, for example, goes here and then here. So when you ping 86, okay, so it means that you are using forward. Okay, so this flow will be used forward because the destination IP address is 86. Okay, but if you ping the router itself here, you'll be using input here. So this traffic will use input. Okay. Now we'll be talking about routing. Oh, I forgot the slides. Sorry for that. Let me check. Oh yes, sorry for that. I forgot to. Okay, I will show you here. Just only one slide. One slide I forgot. Really sorry for that. Okay, just one slide. So yeah, so routing and router. So these are two different things. So router is the device. Routing is the process. Okay, so when we learn the what is it? When we learn the routing, these are two things that you need to understand. Okay, so put them here. Okay, looks good. So you know the 7 layer of OC. Okay, so on layer 3 we have a network layer, and then inside the layer we have protocols. Okay, so layer 1, I mean usually from top to bottom, right? So layer 1, 2, 3, 4. So on layer 3 here we have protocol. Okay, and then the protocol, most protocol, most common protocol used on layer 3 are IPv4 or IPv6. Okay, so there requires here the IP addresses. Okay, IPv6, IPv4 only 32 bits, but IPv6 has 128 bits, so 4 times larger. So router here is the physical device. So here it is. If you draw, and then it's going to be like this. This is the router icon. And then routing is the process for selecting path for network. So if you want to go somewhere, and then here's the gateway. So basically, the routing process will generate the routing uh, routing table. Okay. So that's all. I think that's enough for this slide. I have updated the slides. Okay, perhaps this one. Yeah, back to the previous slide. Hello, can you hear my voice? I just got the. Oh, okay. Oh yeah. Hello, can you hear my voice? Oh, okay. Yeah. Yeah. Sorry for that. I was asking because I just got a notification here from Zoom saying that I was logged out. I don't know what it means here, but I'm still be able to stream out to you guys. Okay, so hopefully everything's okay. Right. So let's continue. Uh, yeah. So this is how you set up your own network, right? So it's a very physical. Okay, physical networks. Okay, so here you have routers, you have another routers, you have another routers, and then most likely it's connected with the switch and then another switch, and then you have a Wi-Fi here. You have wired connectivity, so everyone here connected through cables. This one is wireless. Okay, so uh, yeah, they are using wireless connectivity. So this is how you set up your own network, right? Okay. Okay, so it's very physical, and then sometimes we call it the physical topology that says the layer 2 connectivity. This is how the cable flow. This is where we put the cables. This is where we put the routers. Okay, those are layer 2. And then after that, we need to talk about layer 3, for example, like this. So this is called logical topology, okay, which consists mainly on layer 3 informations. So here, we only focus on layer 3 devices such as router, okay, and then we focusing on the network that is connected by the routers here. So in this picture, um, we have four networks. Okay, so the first network is here, second network, third network, and fourth network. And on every router, you will have a routing uh, routing table like this, which is say that okay, if you want to go here, use this gateway. If you want to go this, use this gateway. And then the way it says is direct because it's directly connected here and there. Okay, this network is similar to this network. This network is this network. So it means that you can go directly. Okay, so that's how you read the routing tables. Okay, what about this one? Well, this network is not directly connected. So this network is similar to that network here. So that's why if you want to go this network, and then you have to use this gateway, which is this one here. Okay. So that's how you read the routing table. So similar things with this one here. Okay. So this network is similar to this. And if you want to go to this network, you need to use this gateway here. Okay, that's how you read the routing table. So all routing tables, all routers must have the routing tables. Okay, so router 1 has these routing tables, router 2, router 3, and so on and so forth. Okay. Okay, so that's how you read the routing tables, and then every router must have a routing table. Okay. Oh, I have questions. Can we get the PDF? Yes, yes. Well, I will upload the PDF on. Usually, I use SlideShare, and then on the the way the way we match the routing table is based on the entries here. So it's similar like a firewall. It's got a match and action. So the action goes for a gateway. A match is for a destination here. Okay, so it depends. So for example, the destination is blah, blah, blah /32. It means that the first 32 bits, if it is similar. So we are always looking for the destination IP address. Okay, so if it is matched to this 32 bits over here, okay, and then go to this gateway. If the, for example, this is /26, it means that the first 26 is matched, go this way. /24 is matched, go this way. And the last one here, if there is no match anything, just send them this way. So this one is called default route. Okay. So default route, it means is the routing entry where the destination IP address is 0000. Okay, I got another questions. Can we get the webinar recording? Yeah. I will upload it on YouTube. Not after this, but later on. Yeah, this is one example. So when a package arrives, okay, so there is a package arrive on a router, and then the package has a destination IP address. See, destination IP address is this one. If you convert the destination IP address is similar to this, and then here's the routing table. Okay, okay, and then just check first. So if the first is similar to this, is it similar? Blah, 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 blah. No. Okay, is it similar? The second one? Blah, 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 blah. So 1 and 2, okay, no, because the first 26 and the first 26 is not similar. So we don't use this one, and then check another one. Okay, so we have a difference here, see? So we don't use this one, and then check the first 24 because this is /24. Blah, 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 blah. Okay, it matched from here to here. Okay, so that's why the package will be forwarded to this gateway. Okay, so when the routing table lookup happens, so this process, okay, the process of the looking for specific gateway here, okay, will be done on this process here, on this stage, yeah, and here, if it is a input. Okay, for forwarding, mostly happens here. Okay, so that's why if you have lots of routing entry, the processing will require more energy. I have one router with BGP full routes. It has 1.2 million routing entries. So it means that every time a package arrives, the router must look up into those routing entries. Okay, so it has to be a very, very tough job. Okay, so those are the places where we process the packets. Okay, next is static routing. So static routing is done. So routing entry is here, and then the way you develop the routing entry, it determines how the routing is created. So if it is created manually, okay, here, so you log into this and then you create this table, okay. you go log into router 3 and then develop the routing tables, okay, blah, 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 blah. And then you log into router 2, okay. And then you develop another routing table here, blah, 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 blah. Okay. Destination, gateway. Here's also destination, gateway. So that way is called manual static manual routing or static routing. So it's manually added by the administrator. And then we have a dynamic routing. A dynamic routing means all routers will talk to each other here. So they are talking to each other, and then they are exchange their routing tables. Oh, okay. So for example, router 1. Well, I have connected to this and this. Okay, here's my information about this network. Oh, okay. Oh, you already connected to that. Okay, I will add this. I will add those in my routing table, blah, blah, blah. So my routing tables is getting bigger because I got information from other routers. So that's how the routing table is developed using the routing protocols, either RAIP, Routing Information Protocol, OSPF, Open Shortest Passwords, or you can use BGP. Well, the drawback, not the drawbacks, I use routing protocol a lot. Mostly I use OSPF or BGP. Mostly we need to understand how the protocol is working. Okay, otherwise you will like kill yourself. You don't understand how the OSPF works. we have we have we have yeah we have courses training for OSPF and BGP. So if you want to certify for OSPF, there is a course named MTCRE. Okay, and then for BGP we have MTCINE. Okay, so MTCINE mostly talking about BGP plus MPLS. Okay, but make sure that before you take the MTCINE, you need to understand how the OSPF works because that one is advanced. Okay, so again, if you want to implement dynamic routing, you need to have a good knowledge about the routing protocols. Okay, I got a question here. So every process using binary ASCII for all IPv4, IPv6, of course. Well, look, guys, if you see an IP address, so everything is on binary. Okay, so computer or routers actually is a computer. So computer only see these things, this string 1010 whatever. Okay, they don't care about 192, 168. They don't care. Okay, so that's just for us as a human. So the way we see, because what is, for example, what is the IP address of yahoo.com? Well, it's 100.101.0.1.1.0. What are you talking about? Okay, so this is very fundamental questions. So when you see an IP address, computer do not see address like we see. Okay, so they just see when IP address coming to the device, they just see a bunch of 10s like this. See, this is how a router works, by reading the binaries. Duh. Okay, but for us, because we are difficult reading these 10s, we classify it as octet. So every 8 bits, we translate it into, okay, 192. This one is for 168. This one is 2. This one is 6. Oh, okay, the IP address is this. But this is just for us. Computer do not need this. Okay, understand? Okay, so think like computer, okay, guys? Think like computers. So computer do not care 192, 168, whatever. They just care about the bits, okay, 1 and zeros. Right. Okay. So just finish. Oh, we're about to finish. Okay. So important to note that with current design, well, the way IP address is designed and then the way the routing design is only one way. Okay. So from, yeah, we have, so we want to talk from this computer to that computer. Usually it's between the server and then the client. Okay. So when client goes to the server, it goes this way. Okay. When the server replies, it goes this way. Yeah. Is it possible? Yes. Why not? Okay. So routing is one way. Now, let's talk about the next concept, which is the firewall for routing. So I have one. So policy-based routing is a feature on routing table. See, this is a routing table, and then the feature on routing table to direct traffic based on certain criteria. So previously, so when we talk about the routing, see, only based on the table like this, right? Okay, so you want to go, if you want to go this, you go this. You want to go this, use this gateway. You want to go this, and then use this gateway. So, uh, so the way you steer the traffic, the way you route the traffic is only based on destination address, right? The destination IP address. Is it enough? Well, in some cases, it's not. Let me tell you an example. Okay, so this is an example. So with policy-based routing, you will set up routes or traffic forwarding based on IP address and based on the routing mark here. So two ways. Okay, so it's got two components. First is the routing entries. So this is an example. And then the other one is the mark packets, which is done by firewall mangle. Okay, I don't put the mangle here. Perhaps I can show you uh, in the demo. Okay, so this is how the policy-based routing is implemented on Mikrotik. So just when you see a routing mark like this on your routing table, and then you will see, oh, okay, this is a policy-based routing. So this rule will be executed after on every packet that has mark like this. Okay, so any examples? Yeah. This is an example, okay? So, for example, so you have two ISP here and here. You are router 1, okay? And this is the connections, okay? You go through 86 and 85. And then you have two clients here. You have router 21 and then router 101. Okay. So what you want is router 21 goes this way. Okay, let me use the color. So you want router 21 goes this way, but you want to use router 101. It's not a 101 goes this way. Okay. So that is one example. Okay, the way to do that, I will share my whole screen. Okay, I will access the router 1. Ah, here it is. So on router 1, this is how it looks like. So we have 2 gateways. Okay, so 85 and 86. So these are 2 gateways. And then the way we do is using this. Okay, okay, I set up. Oops, I set up destination is 000, and then the gateways is on 86. Okay, so let me turn off the what is it, OSPF, because there is an OSPF running on this one, especially when they are distributing the static routes. Yes. Okay, never, and then off you go. Ah, see, great. So we just only have two. Oh, okay, let me log into another host here. 22.101. Another admin, yes, okay. So I have okay, so I have a client here connected to router 1. Okay, and the IP address is IP address show. So this is the IP address. Okay, so 11.1.21. It's connected to router 1 here. And then I can ping, for example, to ping, trace route to, let's say 8888. Okay, so it's not working because why? Why? Because I don't put any default network here, right? I don't put the default gateway. So when I turn on this one, okay, this is the default gateway, a very simple one. So it's saying that if I want to go to default and then use the router 86. So let's try, and then this is what happened. So as you can see, from the host 101, I can go through router 1 and then router 86. Okay, so it's very simple. And then when I turn on this one, so I will turn off this one and then turn on that one. So I will go through 85. So this way. Okay. Okay, do the trace route again. Oh, the 85 is not working. On 68.85.85, for example. Oh, 85 is not running. Okay, let me check. Yeah, it should be okay. Yeah, let me check 192. 168.85.85. Yeah, it works. It works. But this one is not working. Okay, I will try to use router 21. Okay, so this is my router 21. Okay, the router 21 has a default gateway to router 1. Okay, let's check the routes. Okay, so here, okay, let's do the trace route with the term from terminal. Tool, trace route 8888. 192.168.85.85. Oh, something wrong happened here. Oh, okay. So there is no turning back. Aha. Yeah, there is no routing back to this one. Oh, yeah. So I need to edit the router 85. Okay. So perhaps I can set up a NAT here. NAT on 85. So ether 6 using masquerade. So hopefully it works. Okay, let's try. Ping. Yeah, it works. Okay. So briefly, it not work. So it looks like I need to set up routing here on 85 back to this one. So back to our topics. Okay. Yeah, see, now it's working. Okay. So again, so if I turn on, again, so if I turn on this one and then trace route to Google goes through 86 here. Okay. If I turn on the second one here, traffic to Google goes to this. Wait, why is not working? So previously it's working. Clear cache files, yeah. Okay, so anyway, let's continue. So here I can put a route here. So when I go to 8888, it says no route to host. Okay, because I don't have any default gateway that is active here. So there is one here, but it cannot be used. See, after I turn on, nothing happens. So it's not like when I activate this one. So when I activate that one, so traffic goes automatically to 86. Okay, I just turn off and then no traffic at all because the default route is not active. So there is a similar like a default route when you see here. Okay, this guy here. Okay, so it's similar to like a default route. Okay, but it's not. This is called the policy-based routing. Why? Because of this guy. Yeah. So we need to have a trigger. So this is the routing mark with the trigger. So we need to mark the packet itself. So how to do that? So we can go to IP firewall mangle. Okay. IP firewall mangle, and then we can add. Oh, this is we already have an example here. Okay, so for example, it's a pre-routing. Yeah. So the source address is 21. Okay. And then the routing mark goes through 86. Okay, and then enabled. See? Okay, so we have two parts here. Again, we have two parts. Okay, first is the routing entry, and then the second is the mangle. Okay, two parts, as I say. So first is the routing entry here, and then the second is the this is the package that is already marked with the routing mark here. So first, this one will be executed first, and then goes to here. Okay, so as the results, I'm from 21. I can go through here. Okay, so it works. So again, when we see the slides, okay, so as you can see, so policy-based routing has, policy-based routing has two parts, okay. So first, it must have a routing entry with a trigger. In this case, is this one. And the second is the mark packets, where we use a firewall mangle for this purpose. Okay. So that's, we conclude the policy-based routing. So it means that we are using firewall to support the routing. Okay. Any questions? Any questions? So sorry, I cannot give you the access to the live practice because this one requires more than one device. As you can see, I have lots of routers here in my lab, and then this is also an example of when you are doing training with us. This is how it looks like. Okay, we give you lots of routers that you need to configure. So hopefully, by configuring those routers, you will understand the material better. Okay, so I think that's all. Time is up. Any question and answer? Yeah, for your information, we have training also in our website. If you are interested, you can join us. You can contact admin for more information. Okay. For feedback, you can submit your feedback on the URL here. If you are feeling if you get more benefit from our webinar, you can like our Facebook page. Slide will be available on SlideShare. Usually we put it on SlideShare. Recording is on YouTube. Okay. And then stay tuned with our schedule. Any questions? Okay, so how will you defeat VPN if unblocking unwanted sites? So how will you defeat VPN for blocking unwanted sites? Well, so you need to understand, again, if you want to block VPN, you need to understand which VPN that is used for those users. Okay, for PPTP, they are using GRE protocol, and then you can block GRE, and then the VPN will not work. Others using other technologies. So I think it's quite difficult to identify VPN technologies because there are so many. Yeah, because if you block and then GRE is not only used by a VPN, it's used by tunneling protocol also for UIP. So make sure that you really understand the traffic, and then it's quite difficult. So with the current Mikrotik features, they don't provide, because that one is the features that requires lots of inspection. And then if it's similar to layer 7, you have to deeply checking the packets, okay, like a packet analysis. So yeah, for me, with using Mikrotik itself, it's not sufficient because Mikrotik is not uh, like is not a company that is focusing on that deep packet inspection (DPI). So you can use other firewall that can do that kind of stuff. Okay, so hopefully that answer the questions. So next is may share the screen. Sorry, I don't understand. Yeah, so better if you put text here. Guys, if you would like you to put your feedback on URL there. Okay, next. I have /28 public IP. I add addresses to Mikrotik a single interface. You have bare metal server or VM with /24. Do I destination NAT Mikrotik after setup source NAT? Oh, yeah, this is a very common. So this is your ISP, okay, and then the ISP, you have a /28 directly from them. So this is their gateway, and then /28 network, okay, and then it means that the IP address on here will be directly on them, okay. So /28 means how many? It's a 2 to the power of 4, right? Yeah, -2. So those IP address must be directly connected to them. Yeah. Okay. So, and this is your router, and then your router is only using one IP of them. Okay. So what you can do, this is your server, and then you can do source NAT. Yeah. I mean destination NAT. Okay. Or you can connect some of them directly to here. Okay. So do I need device like a Fortinet for security? Well, that depends on what kind of security. So for me, I use Mikrotik behind. So our server is here. Okay, and then here's the Mikrotik. Well, that depends on the security that you're talking about. For me, yeah, my setup is simple. This is a router, and then this is ISP, and then as simple as that. Okay, so hopefully that answers the questions. Okay. Oh, okay. Oh, okay. So you have lots of NAT here. Okay. Well, again, so that depends. I'm not talking about the NAT here because, yeah, it's like a kind of consultant jobs here because here we only have 1 hour. Okay, so I have another question. Oh, okay, another question. So what is it? So hopefully you can, that answer the questions, Muhammad Sefrian Noramza. And then Momo Cha. Okay. Can we get certification for this webinar? Please contact admin. Yes. Yeah, that's the WhatsApp. Okay, I think that's all. Admin, off you go. I think time is up.
Okay. Yeah, thank you. Thank
Goodbye
you
for
so much,
everyone.
guys, for your kind attending our webinar today. Thank for attendance. We hope this webinar gave you a good benefit or value and it will be useful in the future. So please submit your feedback because really this feedback is really important to us. And if you have any suggestion about next webinar topic, can you please mention there? And for the further event, maybe you can visit our website. You can also follow our social media, YouTube, Instagram, Facebook, and also join our Telegram community as well for the information next. And the last
Yeah, it's a
request, can
photo
you please,
session.
sorry?
Photo session.
Photo session, yes, great. Together, can you turn on your video,
Okay,
please,
guys, please turn
for the
on your video.
documentations?
Right.
Hello.
Hello. Yeah.
Yeah, you can
Finally, you
unmute
have.
yourself if you want to ask something.
Right. So, okay, I'll count 1, 2, 3. Okay, done.
Smile,
Smile.
maybe
And
two
then the
thumbs
next
up,
page.
maybe.
Yeah, thumbs up. Okay. 1, 2, 3. Great.
Great, thank you so much. Oh,
Right.
okay.
Thank you.
So can you please fill up the feedback? So it's
Yeah.
really important to us.